Hello, I am Dr. Badarinarayan, the principal of MS Engineering College. I welcome you for a discussion on solution to linear programming problems using graphical method. In my discussion, I take a simple problem, linear programming problem, in which we have to find out the minimum value of z is equal to 2x1 plus 3x2 subject to different constraints x1 plus x2 less than or equal to 27, x2 greater than or equal to 3, x2 less than or equal to 12, x1 minus x2 greater than or equal to 0 and x1 greater than 0 and less than or equal to 20. This is the linear programming problem we have. Now let's go and find out how do we get the solution for this particular problem using graphical method. So basically in the graphical method we make use of a graph sheet. So in which here I consider one division is equal to 3 units and I mark x1 along the x-axis and x2 along the y-axis. Now what are the constraints we have? The constraints I make it equal to, when they become equal to, it forms a straight line. So I try to plot this particular straight lines onto this particular graph. Now let's take the first equation, x1 plus x2 less than or equal to 27. So when I make it equal to, it becomes x1 plus x2 is equal to 27. So for this equation, I substitute x2 is equal to 0, then I'll get x1 value equal to 27. And I substitute x1 is equal to 0, I get x2 is equal to 27. That means to say, if I connect x1 is equal to 27 and x2 is equal to 27, it becomes a straight line. Now, the question is, what is the solution? The solution is nothing but the value of x1 and x2. Suppose if I take any value here, now let us take x2 is equal to 3 and x1 is equal to 12. That means it becomes 12 plus 3 is equal to 15, which is less than or equal to 27. That means to say any value which I take less than this particular or below this particular line will satisfy this particular equation. Now if you take any value or solution above this line, for example, let's take 27 and 6. So 27 plus 6 is equal to 33. 33 is greater than 27. It's not less than or equal to 27. Therefore, any solution which comes above this line does not form a solution or a solution which satisfies this particular constraint. Therefore, the solution now will be below this particular line. Now similarly, we take the second equation, that is x2 greater than or equal to 3, convert it to an equality. That means it becomes x2 is equal to 3. Now let's plot that. Now x2, the equation is x2 greater than or equal to 3. That means to say the solution now lies above this line. Any solution below this line does not satisfy that inequality. Now let's go for plotting the third equation. The third equation is x2 less than or equal to 12. That means to say I draw a line corresponding to x2 is equal to 12 and now the solution space is less than. So therefore, if I identify any value x2 is equal to 9, it lies here. So therefore, any solution that is falling below this line satisfies x2 less than or equal to 12. Therefore, the solution space will be below this particular line. Now let's consider the another constraint. Next constraint, x1 minus x2 greater than or equal to 0. Now in that I substitute x1 minus x2 is equal to 0. That means x1 is equal to x2. If I plot that particular line, I'll get a line like this. So now what is the solution? Whether it is below this particular line or above this line. Now substitute any value x1 is equal to x2. That means it will be a 45-degree line. Now what is the solution? Now the solution, if you take, now suppose we take a solution x1 is equal to 12 and then 6. So 12 minus 6 is 6. It is greater than or equal to 0. Therefore, any solution less than this particular line satisfies that particular inequality. Now consider last equation, last inequality, x1 less than or equal to 20. So if you write the particular equation, then we get another straight line, vertical line, x1 less than or equal to 20 or x1 equal to 20. Now where does the solution lies, whether it's to the left of this line or to the right of this line. Now if you look at any value, now suppose if I take x1 is equal to 18 or 12 or 15, it lies to the left side of this line. Therefore, the solution will be to the left of this particular line. So after drawing all the lines, what I do is, now I get a feasible solution space. Now what is this feasible solution space? The feasible solution space is nothing but the solution which satisfies all the constraints simultaneously. So any point or any solution I take in this particular zone is going to satisfy all the constraints simultaneously. Then I say that I have a feasible solution space. Now the challenge is we have infinite number of solutions in this particular space. Now how do we get the optimal solution is the next question. Should we go for calculating all these feasible solutions? It's quite impossible. Therefore, we just calculate the solution at these corner points. So the corner points are A, B and C and D and E. Suppose if we calculate the solution at these corner points, we'll be able to get in any one of these corner points, we'll be getting the optimal solution. Now let's calculate at this particular points A, B, C, D, E, what are the coordinates and what is the Z value. At A, the coordinates are 3, 3 and the Z value will be 15. At B, the coordinates are 12, 12 and the solution is 60. At C, it is 15, 12, the solution is 66. At D, it is 20, 7, the solution is 61. At E, the solution is 20, 3 and the Z value is 49. So if you look at now, the objective is minimization. Therefore, the minimum value is 15 and corresponds to 3, 3. That means the value of solution x1 is equal to 3, x2 is equal to 3 and the value minimum will be Z is equal to 15. In the same table, we can also identify what is the maximum value. That is x1 is equal to 15, x2 is equal to 12. We will get a maximum value of 66. I hope you understood how to solve linear programming problem using the graphical method. Thank you for watching. Please subscribe to MSEC channel.